Zhang, a third-year student in mechanical engineering, and I will be presenting today. I do like to introduce the basic of reference learning. Instead of diving into complex details, I will focus on explaining terms and the overall flow. I will present in the order of definition and terminology, QR algorithm, and DQN, and then conclude. Here is the definition of the reinforcement learning. Reinforcement learning is a machine learning technique that allows an agent to learn in an interactive environment by using feedback gained from its own actions and experience. Here is definition of. Now let's go over some key terms in reinforcement learning. Understanding these terms will make it easier to grasp the main concepts of reinforcement learning. First, agent. This is the intent that acts to achieve a goal within an environment. Next is state. This refers to the current condition or situation of the environment. Then we have environment. This is the system with which the agent interacts. Following the reward, this is the feedback given to the agent for its action, indicating progress toward the goal. After that action, these are the choice or moves the agent can make based on the current state. And finally, police. This is the rule or function that guides the agent's action in each state. On each example would be the Mario game. In this case, Mario is the agent, and the environment includes rocks, animals, and power up. State might be Mario is facing an enemy, or Mario is jumping toward coin. Rewards are given when Mario collects coins or defeats enemies. Actions are things like jump or ducking. And policy would be jump if there's an enemy, or jump if there's speed. Now let's talk about policy bias or policy in reinforcement learning, as shown on this slide. First is on policy. On policy learns from each action as the agent interacts with the environment and immediately modifies the policy basis on that experience. As you can see in the pictures on the left, the process is defect as the agent, the director, interact with the environment and conditionally updates the police. On the other hand, of police reinforcement learning is different. Here, as agent does just to learn from its own current police, but can also update based on experience from previous or other policies. The following are the type of the algorithm. The Q learning algorithm is an algorithm that learns optimal behavior by storing it in a matrix of state action pairs. And DQN is an instance of Curani that can be applied even in complex environment by using these matrices using a neural network. Lastly, the SAIC algorithm. The SAIC algorithm is a reinforcement learning that updates the actor and critics separately. In the next presentation, I will explain the neural network part of DQN and the SAIC algorithm. Here is the detailed explains Q-running. The Q-running algorithm uses the Q function to update based on state-to-action pairs, applying a discount factors to reflect the value of future reward in the presentation. Present. The, the figure below illustrates a maze explain. The agent starts from a position and must avoid obstacles to reach the goal. These different rewards are assigned to each action. Through this process, the agent learns which action is optimal for each state. In the figure on the right, rewards are set so that hitting will result in -2, and non-collision are assigned -1. This reward structure guides the agent to avoid the worst action, gradually learning to select optimal actions. True. To determine the optimal actions, I will apply to a discount factor. The discount factor is a value between 0 and 1, providing feedback on the probability of encountering obstacle. This reduces the reward over time, allowing the agent to run the optimal actions. I'll explain the function in simple terms. The Q-learning, also known as the state action value function, takes the state and action values as inputs and returns on output. It may sound complex by definition, but essentially it tells me how much reward can be obtained through Q. In other words, finding Q means running Q. By finding the policy where Q is maximized, I can identify and take the action that provides the maximum value. The formula is shown in the figure on the right. Our preferred experiment TQN TQN combines the Q-learning algorithm with a neural network. In other words, it is a reinforcement learning algorithm where I use a deep learning neural network based on the Q function to run optimal actions, making it stable or takes that require high performance. Q-learning stores the Q function is a matrix format to estimate and run it. However, as the number of actions and state increases, the matrix become too large to estimate efficiently. To solve this, TQN use a neural network to optimize and estimate the Q function. I plan to research the neural network component further and include in my next presentation. This concludes my presentation. Thank you.